Okay, this question is quite a tough one because it doesn't really ask you a great deal, and I think you've got to expand on things a little bit more to make sure we get the marks. It's worth 6 marks. So, talk about a catalyst. The first thing I would do is I'd draw on my diagram what the energy profile would look like if we had a catalyst. So this is the reactants activation energy coming down to products normally. So I've labeled there the activation energy so you can see how much energy that is. And then I've drawn for myself a second line in here showing that the activation energy with a catalyst, and this energy is lower than it was originally. Okay, that's really important to show that. Then let's put some facts in. So catalysts speed up reactions. How do they do it? They lower activation energy. How do they do that? They provide an alternative pathway for that reaction to take place. Catalysts themselves does not take part in a chemical reaction, therefore it's unchanged and its mass is unchanged. So what you put at the beginning, you will get at the end. Other things to then talk about is explain reaction particle theory. So that a reaction to take place, the particles must have a minimum amount of energy when they collide, and this is called the activation energy. A catalyst lowers the activation energy, meaning that there are going to be more particles now whose energy is greater than the activation energy required to react, and therefore the reaction is going to happen faster. Then we can chuck in some examples. So ones you've come across, you know that iron is in the Haber process. You know that there's enzymes are biological catalysts. We've talked in class about enzymes in yeast that are used to make alcohol. And we've also talked about catalytic converters in car exhaust systems, as well as another example.